Hi, today I'm going to show you how to solve a problem in HackerRank. So this is the fifth video in this challenge, solving problems in this platform. So let's get started with the instructions here. Given a square matrix, calculate the absolute difference between the sums of its diagonals. For example, the square matrix R is shown below. 1, 2, 3, 4, 5, 6, 9, 8, 9. The left to the right diagonal is 1, 5, and 9. 1, 5, and 9, and the sum of this it will be 15. And the right to the left diagonal it will be 3, 5, and 9, and the sum it will be 17. So the absolute difference is 15 minus 17. In absolute it will be 2. The function description: complete the diagonal difference function in the editor below. Diagonal difference takes the following parameter: an array of integers. Yeah, this is a matrix. So we have two different counters for n and for m. Two different positions because it's a matrix. So here we have columns. Here we have columns, and here we have rows. So we just need to return the absolute diagonal difference. In the input format, the first line contains a single integer n, the number of rows and columns in the square matrix R. And each of the next n line describes a row R in position I and consists of n space-separated integers R in I and in j. And here we have the constraint and the output format. Return the absolute difference between the sums of the matrix two diagonals as a single integer. The simple sample input, it will be 3 because we have 3 columns and we have 3 rows. So the sample output it will be 15. And the explanation here: the primary diagonal is 11, 5, and minus 12. So here we have 11, 5, and minus 12. This will be like the primary diagonal. And the secondary diagonal it will be 4, 5, and 10. And sum across the secondary diagonal it will be 4 more 5 more 10, it will be 19. And the difference, 4 minus 19, it will be 15. Well, minus 15, but it is an absolute value, so it will be 15. And later here we have the code. So first I'm gonna do, it will be like comment the instructions or the steps, the different steps. So first I will define our variables for the counters. Define our variables for the counters. So I'm going to create the primary diagonal. It will be like the accumulated value for the primary diagonal, or the sum of all the values. So it will be by default 0, and the secondary diagonal it will be 0, 2. So here we have our variables. Later we need to just iterate through the array in rows. So here we have iterate through the array in the rows, because it is a matrix. So first we need to go inside the rows. So for we're going to throw every single item in the array. First we need to go in the rows. So we're going to create two different counters. In this case we're going to start with an I counter. It will be for let I equals 0, I minus then R point length, and I plus I plus plus. So yeah, it will be like these are the rows, and later we're going to iterate in the columns. So iterate in columns. So we just need to add another 4 let j equals 0 because we need two different counters. In this case it's gonna be j equals j minus r point length, so j plus plus, and we just need to add these brackets. And later we just need to add the conditional for the primary diagonal for find the different items. We just need to sum. So add conditional for find the items in primary diagonal. So here we have. So how can we know that we are in the primary diagonal? For example, we know that it's gonna be, in this case, 1, 5 and 9. But how can we know in code? For example, we can know this with the positions in the rows and in columns, because when we are in position 0, 0, we have 1. When we are in position 1, 1, we're in 5 value. And we are in position 2, 2, we are with the value 9. So, I mean, when we are in the same position in I and in J, we are in the primary diagonal. So we just need to add this conditional. So if I equals j, it will be the primary diagonal. So we just need to sum. Primary diagonal, it will be the same value or the current value as primary of the primary diagonal plus the value we are finding right now in this moment when we are in this conditional, with this conditional. So r in the position I, in the position j, because we just know that I is equals to j. So we are in one of these values, 1, 5 or 9. So later this is gonna be like all for the primary diagonal, for the accumulated values for primary diagonal. And how we can know that we are in the secondary diagonal? We just know that we are in the secondary diagonal because we are incrementing in our rows, because for example in this case the row is 0, the row is 0, the row is 1, and the row is 2, but we are decrementing the value for our columns, because the column here is 2, the position of the column is 2, and the position here is 1, and the position here is 0. So we are incrementing in rows but decrementing in columns. So we just need to find like the pattern here. So I found it. We can just add this. I found that we just can't add this. Well, this is not like a conditional, this is like a pattern. So the secondary diagonal, it will be secondary diagonal. It will be the current value of the secondary diagonal plus the array, the current array in the position I. It will be for the rows. So in the position 0, in the position 1, in the position 2, and later find the position for the columns, because we are decrementing our columns. First we have in the column 2, in the column 1, in the column 0, so we just need to decrementing, and we are in the lattice position for our column first. So we just need to add this r in the lattice position. We can know with the length of our array minus 1, because our length is not like the same for our positions. For example, in this case, our length is 3 because we have 3 different items. But for our positions, we have 0, 1, and 2. So our positions are like minus one number in the length. So this is why we need just to add this minus 1 unit. So it will be this position, and how we can decrementing in the next step in the next iteration, because if we just add this, it will be always the latest position for the row. So we just need to add minus the current row, the current position for row. For example, in this case, the row is 0, so the position it will be 0. But in the next, it will be minus 1 unit, so it will be 6 minus 1 position, it will be this position, the position 2, because the position was 3, and minus 1 position it will be the position was 2 minus 1, it will be 1. So this is this. And at the end, we just need to rest the row 0, 1, 2. So we just need to rest 2 units. So in this case, we are in the latest position for the column minus 2 units. So it will be 2 minus 2, 0. So 2, 1, 0. So it will be this 9. So here we have our secondary diagonal 3, 5, 9. So we just need to here, and here we have everything. That's all in this case, and we just need to outside our for each. Outside of our for each, we just need to add this. Do the rest with the absolute value. So first we need to just create this operation, return our primary diagonal minus our secondary diagonal. So this is like the operation, but with this we don't have our absolute value, so we just need to add this method. It is from this library math. Math is native from JavaScript, so we just need to add this and it will be converted to an absolute value. So I think that's all for this video. So we just run code. We're going to just run the code, and yeah, the sample test case 0 is successful, and submit code. And yeah, here we have the success. You solved this challenge. Would you like to challenge your friends? And yeah, I think that's all for this video.